Good morning. In this video, we are going to discuss about corrosion control in that metallic coatings and electro as well as electroless deposition is the topic we are going to discuss in this video. I am Dr. R. Srinivasan from Chemistry Freshman Engineering, IARE, Hyderabad. So this corrosion control, in this we will see metallic coatings, electro deposition, or we can also say electro plating. We can also say electro plating or electro deposition, electroless plating, or we can say electroless deposition. So this comes in module 1. This is course outcome 1, Bloom's taxonomy understand, and course outcome is explain the electrochemical principles, corrosion process in metals for protection of different metals from corrosion, and electroless deposition is also explained as an extra information in addition to electro deposition. Okay. So in this first we'll start with metallic coatings. Both this metallic coatings and electro deposition comes under surface coatings. So what is surface coating? The metal surface is covered with a coating to protect the base metal from corrosion. So the ways of doing this surface coating is by metallic or organic. So we will be interested in metallic and we will not see in this video about organic. We will see only metallic. Okay. First, metallic coatings. Metals used for coatings may be placed under two categories. First one is metal which are anodic to the base metal. Metals which are anodic to the base metal, that is metals above in galvanic series, example zinc. Okay. And metals which are cathodic to the base metal. Okay. Metal here means base metal, that is metals below it in galvanic, example tin. So we have seen electrochemical series, like for example minus 2, it will be keep on decreasing 0 and then it will go to plus. So here zinc is here, okay, minus 0.76. Copper means we have seen plus 0.34, like that. Okay. So above it in galvanic series, metals above it in galvanic series, metal below it in galvanic series, and this is like electrochemical series or EMF series we remember we have seen in electrochemistry. Okay. So under metallic coatings depend on the metal lie above the base metal or below the base metal. We have two different types of coating. One is anodic coating. Anodic coating means, for example, coating of aluminium, cadmium on zinc on steel, that is iron surface, are considered as anodic because their electrode potentials are lower than that of the base metal iron. So iron is a base metal. So you coat it with more negative metal, for example aluminium, cadmium or zinc. Okay. So then this comes under anodic coating. So anodic coatings basically protect the underlying base metal sacrificially, meaning is when you do anodic coating to a base metal iron, this above coating will sacrificially undergo corrosion by protecting the base iron metal. Okay. Even the formation of pores and cracks over the metallic coating, it exposes the base metal, and whenever there is a exposure, because due to pores or cracks, there will be a galvanic cell formation, anodic part, cathodic part, between the base metal and the above coating metal. So the coating metal dissolves anodically and the base metal is protected. Exposed substrate will be cathodic and will be protected. That's why even if there is some cracks or pores, the exposed metal iron will be cathodic, so it doesn't undergo corrosion. So the coated material sacrificially undergo corrosion. Okay, thereby the metal iron is prevented from corrosion or protected from corrosion. Next, cathodic coating. What is cathodic coating? Cathodic coatings are obtained by coating a more noble metal, that is metals having higher electric potential. Example, tin, gold, Ag, platinum than the base metal. For example, iron, base metal, or some other base metal. So tin, Au, Ag and platinum are having higher electrode potential. So this comes under cathodic coating. Cathodic coating protects the base metal when the coating, cathodic coating protects the base metal only when the coating is uniform and free from pores. Because when you have pores or crack in the film above the base metal, this crack or pore exposed position will act as an anode. So there will be a small anode and big cathode region, so which will increases the rate of corrosion. The formation of pores over the cathodic coating exposes the base metal, which is anode here, to environment, and a galvanic cell is set up. So because of this small anode area and large cathode, it leads to rapid attack at the damaged area. For example, in this area or in these regions. Okay, so there will be a more rate of corrosion will be increased several times due to the setup of small anode and large cathode. Okay. Next, how will you apply this metal coatings to the base metal? There are different methods of application of this. Application means apply the metal coating over the base metal, like hot dipping, flame spraying, cladding, electroplating, vapor deposition, etc. Electroplating is also called electro deposition. You can say electroplating or electro deposition also, you can say. Both are same. So we will particularly be interested in hot dipping method, which is a more common technique used to do, which people prefer to do, and it is also more convenient and cheaper version to do metal coating for base metal. Hot dipping. What is hot dipping? This technique is most widely used to control corrosion. Hot dipping is used for producing a coating of low melting metals, zinc, tin, lead, aluminium. For example, these are all coated over the base metal. Okay. Iron, steel, copper, which are having higher melting point, usually underwent into corrosion due to their oxidizing property. That means iron, copper, steel, these are all base metal. Process in general consisting of a metal immersed in the process, hot dipping process, in general consisting of a metal immersed in a bath of its molten coating and covered by a molten layer. Okay. And also the flux will be used here, which will cleanse the base metal and prevent oxidation of metal coating with molten solution. We will see this in detail in the process in the coming slides. Okay. So the process in general consisting of a metal immersed in a bath of its molten coating and covered by a molten layer. For example, if you want to coat zinc, okay, it will be dipped in a zinc salt solution, and there will be a flux which will cleanse the base metal, and also it will avoid the oxidation of coating metal. So we will see this in the process. Hot dipping is widely applied either by galvanizing. For example, zinc coated over the base metal iron is, we call it as galvanizing. Tinning, tin coating metal over the base metal iron, we call it as tinning. Okay, these two examples which are widely applied either by this hot dipping method, we will see as an example. Okay. Galvanizing. First, galvanizing. What is galvanizing? It is a process. It's a very important process. It is a process in which iron or steel is protected from corrosion by coating with a thin layer of zinc. Okay, zinc is done. Okay, zinc. Iron or steel. In this process of galvanizing, iron or steel is first cleaned by pickling process. Pickling with dilute H2SO4 solution for 15 to 20 minutes at 60 to 90 degrees. Why this is done? Because the steel is then washed well and dried. It will cleanse the surface which we need to coat it with zinc. So before the coating process, we need to do clean the surface by pickling process with dilute H2SO4 at 60 to 90 degrees centigrade for minimum 20 minutes, 15 to 20 minutes. Then the metal sheet is dipped in a bath of molten zinc maintained at 425 to 430 degrees centigrade. Molten zinc. So here the flux can be ammonium chloride or you can use zinc chloride. And the molten coating metal is zinc or we can use tin. Okay. So here now the surface of bath is kept covered with a ammonium chloride flux to prevent the oxide formation. That means zinc should not get oxidized during the process to zinc oxide. Okay, because zinc can undergo easily oxidation. So in order to avoid the zinc to zinc oxide formation over the surface, we use ammonium chloride or zinc chloride flux to prevent the oxide formation. Metal sheet, once it is dipped in bath of molten zinc maintained at 425 to 430 degrees centigrade, and then it will pass through the flux in order to avoid the oxidation. Okay, oxide formation. Then the metal sheet is passed through a pair of hot rollers which removes the excess of zinc in the surface and maintain uniform thickness of zinc on metal sheet. Uniform layer of zinc over the metal sheet. We will see that process in a diagrammatic way. See, for example, we have a roller which enters into different baths and then drying chamber and then again another bath and then to the another annealing chamber. First, this is iron sheets which is rolled over. First it is rolled into a H2SO4 for pickling the surface of iron sheet. Then after it is washed and then it is rolled over to a drying chamber. Okay, so this is the drying chamber. And then it is rolled over into a, so everywhere we have put arrow mark. So similarly here rolled over into a molten zinc at 425 to 430 degree centigrade. And then this roller will go through the pair of hot rollers. What happens here, when the roller moves, the sheet moves between the two rollers. The sheet moves in this direction. The rollers, what happens? When it goes forward, the excess zinc will be stored here, will be removed and stored here. And this rolled zinc coated iron sheet will be galvanized by a annealing chamber. That is, galvanizing sheet means zinc coated over iron. So it is annealed in the annealing chamber and then whatever comes out, we call it as galvanized sheet. Okay. So the sheet is subjected to annealing process at 65 degrees centigrade and cooling. After this place, this is the annealing chamber at 65 degrees. We are annealing it. We are heating. Heat process. Annealing is a process of heat treatment, and then it is cooled down to room temperature. Okay. So what you get is a galvanized iron sheet. Okay. What are the uses of galvanization? It is used to protect iron from roofing sheets and wires, pipes, nails, bolts, screws, buckets, and tubes. These are all the uses of galvanization. Wherever the iron in this applications are there, because of the presence of zinc over it, their corrosion is protected. Okay, what is a defect? Galvanized utensils are not used for cooking because zinc can solubilize. That is, solubility of zinc can affect the foodstuff. So, it is not used for cooking. Okay. Next, tinning. What is the process of tinning? Tinning is the process of coating tin over the iron sheet or steel articles. Okay. Here again, the process is the cleaned iron sheet is passed through a molten flux. How it is cleaned? Again through pickling, salt pickling in H2SO4, as we have seen in the previous, with the like we have seen here now, 15 to 20 minutes, 60 to 90 degrees. Same way here also the iron sheet is cleaned by pickling process through H2SO4, which is further passed through a bath of molten flux, then passes through a tank of molten tin, and finally through the layer of palm oil, which will protect the hot tin coated surface against oxidation. In galvanizing, we see it is ammonium chloride or zinc chloride. Here it is palm oil is used for preventing the oxidation of tin on the surface. Okay. See, for example, here. So again we have a rollers, and then the iron sheet is coming here, acid pickling bath, then the sheet is sent to the molten tin through we have a bath of zinc chloride flux. So if you pass this through this, okay, this molten tin, and then here there is a flux to prevent the oxidation of tin, and then this sheets are rolled to the through the palm oil to the outside. This is reason for avoiding the palm oil, which protect hot tin coated surface against oxidation. Okay. Okay. Then this is rolled into a outside, which is which is tin plated sheet. Okay, tin plated sheet. So, what is the uses of this tin plated sheet? It is used for coating of steel, copper, brass, and bronze. That is, copper and brass and bronze. These two are alloys of copper. Steel and copper. It is used widely for coating steel, copper, and alloys like brass and bronze. It is used to store foodstuff, ghee oils, kerosene, pickles, and also used for refrigerator equipment. So tinning is used for packing foodstuffs. Okay. Next, electroplating is another type of surface coating. We can say electroplating or electro deposition. What is electro deposition? Electrolytic deposition of coating metal on the base metal by passing direct current through a solution which contain the soluble salts of the coating material. Okay. So, electrolytic deposition of coating metal on the base metal by passing direct current through a solution which contain the soluble salts of the coating material. The common coating metals used are zinc, copper, nickel, chromium, silver, platinum, gold, etc. Okay. Electrode deposition is an important and frequently used method in industries for surface coating. Okay, what are the essential components of this electrode deposition process? An electrolytic bath containing the conducting salt and the metal to be plated in a soluble form, as well as buffer and additives. Okay, these are all the things which is there in electroplating bath. And electronically conducting cathode, that is article to be plated. Article to be plated or article to be the electrode deposited will be in the cathode. Electronically conducting anode. Okay, electronically conducting anode, the coating metal itself or an inert metal of good electrical conductivity like graphite is used as a anode. An inert vessel to contain all the above parts, okay, cathode, anode, and the buffer and additives, that is electrolyte part, made up of either rubber lined steel, plastic, concrete, or wood. So these are all the components used for the process of electrode deposition. Okay, what is a characteristic of a good deposit? After electrode deposition, what are all the characteristics you look for a good deposit? Deposit should be continuous, uniform, non-porous, and adhesive. That is how you want to do the electrode deposition. It should be fine-grained nature. Okay, should be of a electrode deposit should be of a fine-grained nature. It should be bright and lustrous, and it should be hard and ductile. Okay, so these are all the characteristics you look for a good deposit, okay, in the electrode deposition process. Next, what are the factors influencing the nature of deposit in electrode deposition? So it depends on, electrode deposition basically depends on current density, metal salt electrolyte concentration, metal ion concentration, agitation, that is with the stirrer agitation, temperature, pH of electrolytic bath, additives, and time. Okay, time of the passage of current, all those things. Okay, so this many factors, it depends on the electrode deposition depends on this many factors. So you require a perfect, you require a more than perfect combination of this, all these things you have to adjust to make a good electrode deposition. Okay, example of electrode deposition, chromium plating is a very famous one which is used. Chromium is plated over iron or other alloys to prevent it from basically corrosion. Corrosion resistance. Chromium plating, corrosion resistance will be very good. So that is the main purpose chromium plating is used. Chromium is one of the widely used metals for electroplating. There are two types of chromium coating. One is decorative coating and another one is hard coating. Okay. So we will see what is the conditions for decorative coating as an example. A thin deposit of chromium 0.25 to 0.75 micrometer is used for decorative coating. Is applied over either copper nickel or nickel undercoat. Okay, above the copper nickel or nickel undercoat, thin deposit of chromium. It gives a pleasing look and non-tarnishing nature of the plated particle. Okay. What is bath composition? That is electro deposition bath. 250 grams chromic acid plus 2.5 grams sulfuric acid per liter. Okay. 250 gram of chromic acid per liter, 2.5 gram of sulfuric acid per liter, and also it should contain 1 gram of trivalent chromium produced within the bath by adding 4 gram of oxalic acid. So chromium will be having chromium 6 and chromium 3. Two oxidation states are there. In chromic acid, we have chromium 6, whereas some out of 250 grams, some 1 gram of trivalent chromium should be there produced. That's why we are adding 4 gram of oxalic acid. Okay. What is the temperature? 45 to 55 degrees centigrade. Current density is 150 to 430 ampere per feet square. Current efficiency 10 to 15%. Anode, insoluble anodes like lead, palladium with 6% antimony, lead with 7% tin, like that. Okay, I think sorry, this is not palladium, this is lead. Lead 6% with lead with 6% antimony, lead with 7% tin. Okay, or simply lead, or used as insoluble anodes. Cathode is optical to be plated. So this is how we do chromium plating, particularly decorative coating, to whichever the article to be coated with chromium. Here we take that as a cathode, article to be plated or article to be electrode deposited. Okay. Next, what are the applications of electroplating? It is most important and frequently used technique in industry to produce metallic coating, and both metals and non-metals can be electrode deposited or electroplated. In metals, the electroplating increases, as I told, important resistance to corrosion, resistance to chemical attack, hardness, wear resistance, and surface properties, in addition to aesthetic look. Okay. In non-metals, electroplating increases strength and decorates the surface of non-metal like plastic, wood, glass, etc. Here, for example, we have shown silver electroplating. So we take silver nitrate and then we take Ag as an anode, and then this is the article spoon to be coated with Ag. So this is cathode. Okay. So this is example of Ag electroplating, where we take the metal salt solution, conducting metal salt solution here in the bath, anode the metal itself, and then cathode is optical to be coated. So Ag under Ag acts as anode. So Ag gives Ag plus electron, and this Ag plus electron gives Ag. Okay. So this is deposited over the spoon. This is silver electroplating example. Next, as we have seen electroplating, which requires electric current. Now we see electroless plating, which doesn't require the deposition by electroless, means without electricity. So what is electroless plating? Electroless plating or electroless deposition is a method of depositing a metal or alloy over a substrate, which can be a conductor or non-conductor, through a controlled chemical reduction of metal ions by a suitable reducing agent without using electrical energy. Okay. So electroless plating is a method of depositing a metal or an alloy over a substrate, which can be either conductor or non-conductor, through a controlled chemical reduction of metal ions by a suitable reducing agent, is called electroless plating. So we don't use any electricity to do deposition in this process. That's why it is called electroless deposition or electroless plating. Reducing agent plays a major role here. Okay. It involves the oxidation of a soluble reducing agent which supports the cathodic deposition of a metal on a catalytic surface. So oxidation of soluble reducing agent is very important in this electroless plating, which is supporting the cathodic deposition of a metal on a catalytic surface. The process uses only one electrode and no external source of electric current, as we have already explained. The solution needs to contain a reducing agent so that the reaction can proceed. Okay. For example, metal ion plus reduction solution. For example, in the solution containing reducing agent plus metal ion, over the catalytic surface, the surface to be coated. Okay, this is auto-catalytic, means that then only it will promote the coating, electroless deposition. It should be auto-catalytic. So some metals can be directly used for electroless plating. Some metals have to be made conducting an auto-catalytic first to then get ready for electroless plating. So when you have metal ion plus reduction solution on the catalytic surface, then you have metal solid deposited on the surface of metal and oxidized product which is soluble in solution. So we have only one electrode, cathode. The surface itself acts as a auto-catalytic. Okay, and deposition will happen on cathode. So the oxidized product will not be having separate anode, it will be in solubilized form in the solution. Okay. Now catalytic materials like nickel, cobalt, steel, iron, rhodium, palladium, all these things. This is transition metal, transition metal, transition metal, transition metal, transition metal. This is a main group. Aluminum is a non-transition metal, main group metal. All these things do not require any surface preparation before electroless plating on them because they are already catalytic metals. So they can, there is no need to make them catalytic. So they can be directly used for the electroless deposition. Non-catalytic metals such as copper, brass, Ag, etc. need activation. Okay, this can be achieved. Activation can be achieved by rendering them cathodic by dipping in palladium chloride HCl acid solution. Okay, then you can use this. After this processing, you can use this for electroless deposition. Non-conductors like glass, plastic, ceramics, etc. are first activated in a solution of tin chloride and HCl, and after rinsing, it is immersed in palladium chloride and HCl to make the surface conductive so that it can act as a auto-catalytic surface before using for electro deposition. Okay. So glass, plastic, ceramics are all non-conductors. So first you have to do this treatment to become auto-catalytic and conductive, and then you can, it's not conductive, more of auto-catalytic. It should act as a catalytic. Surface should be auto-catalytic. It should act as a catalytic for the deposition of metal by electroless plating. Okay. So we will see one example of electroless plating. What is there in the electroless bath? That means electro deposition bath or electroplating bath. Electroless nickel plating we will see as an example. So what are all the things will be there in the electroless bath? First, metal salt to provide metal ions for deposition over the auto-catalytic surface of the metal. Nickel 2 plus ion it's added in the form of chloride or sulfate salts of nickel chloride or nickel sulfate. Second, important reducing agent for reduction of metal ions to metal atoms. For example, hypophosphite ion. And there are also other examples like formaldehyde, hypophosphorus acid, sodium borohydrates, alkaline diboranes. All these things can be used as a reducing agent. Here we say hypophosphite ion. Okay. Complexing agent. What is the role of complexing agent? It is used to complex the metal ions to prevent bulk deposition. The selection and concentration must be considered very carefully because if all the metal is heavily complexed, then there will not be any free metal ions which is available for electroless deposition. So, what is complexing agent? That is, for example, you have seen AgCN2. Okay, this is a complex. Complex means always we write this in the square bracket. Meaning, in solution, they will remain as AgCN2 minus. Okay, AgCN twice minus. They will remain. They will keep the identity as such. They won't split like normal ions, Ag plus and the 2Cn minus, like that they won't further disintegrate into simple ions. They will maintain their integrity. So that is called complex ion. So if you complex all the metal, there will not be any free ions available. So we have to be very careful in choosing the selection and concentration very carefully. So that sufficient free metal ions will be available for deposition. Why we need this? Because all the metal ions will get reduced and that just over deposition will happen. Okay, the bulk deposition will happen. In order to prevent that, in order to do the coating, in order to do the deposition in a very controlled way, we have to complex certain metal ions, and certain metal ions should be free. Okay, organic acid like lactic acid, propionic acids or salts also as buffers like trisodium citrate are used as a complexing agent. At the same time, it can also be used as a buffers. Okay, buffers are basically to control pH of the bath. Stabilizer will be there, which give more stability to the solution of the bath in electroless plating. Exaltant or accelerated to increase the rate of plating. Other additional agents, additives like brighteners, or will be used in the electroless bath. Okay. What is a typical reaction condition for nickel electroless plating? Nickel chloride 20 gram per liter, sodium hypophosphate reducing agent 20 gram per liter, sodium acetate 10 gram per liter, sodium succinate 15 gram per liter, temperature is 90 degrees centigrade, pH maintained is 4.5. So at this typical reaction conditions, we will get nickel electroless plated material. So nickel deposit formed by the above conditions contains phosphorus to the extent of 3 to 15%. So we can also say this as nickel phosphorus electroless deposition, or we can say nickel and phosphorus is 3 to 15%. Okay, what is the chemical electrochemical reactions involved in this cathode? You know that nickel 2 plus ion get reduced to nickel. Anode is nothing but it is in the form of solubilized in the solution. Hypophosphate H2PO2 minus ion will get oxidized to H2PO3 orthophosphite ion. So this will be soluble, this will be in the solution. This will be plated over the metal surface. So overall reaction is this: nickel 2 plus H2PO2 or hypophosphate ion plus H2O gives nickel plus orthophosphate ion plus 2H plus. So one here, this reaction is in the soluble form. This is electroless plated cathode. Okay, so this is how electroless plating functions. Okay, what are the common metals deposited by electroless plating? Copper. And what is one important application of copper electroless plating is, it is used for electron conductive PCBs, printed circuit boards. Okay, printed circuit boards, both sides it can be made copper coated, so that you can use it either side, and also it is acts as a electron conductive PCBs. Okay, this copper electroless plating is used in PCBs. Okay, nickel phosphorus, the example we have seen is for corrosion resistance, steel or aluminium. Example, metal, base metal. Nickel phosphorus plus PTFE, polytetrafluoroethylene particles, is used for self-lubricating anti-stick coatings. Okay. Advantages of electroless. This is the different example people use to deposit by electroless plating. What is advantages of electroless plating? Doesn't require any electrical power source or accessories. More uniform metal coating over an article irrespective of its shape or size, which is important. Okay, irrespective of its shape or size, we can use electroless deposition as a choice. Only requirement is the solution has free access to the areas to be plated. Okay, that is that irrespective of its shape or size, if the area to be plated is free access to the solution, then electroless plating can be done. It is applicable to conductors, semiconductors, and non-conductors like plastics, okay, ceramics, woods, etc. Depositions are less porous than electroplating. Okay, this is important point in electroless. It is less porous than electroplating, and general possess unique characteristic like chemical, mechanical, and magnetic properties once the coating is done. Okay, fine. There are some limitations also for electroless plating. This high chemical cost, slow coating rate 2 to 25 millimeter per hour, poor stability of the solution, bath solution, careful analytical control of the bath is required. So these are all some of the limitations or some of the disadvantage also, you can say. Coating, slow coating rate. Okay. Okay, with this I am completing this video, and throughout this video the reference is majorly from Engineering Chemistry by R.V. Gathak and A. Nityananda Shetty. Okay, so with this I am finishing this video.
Like, share and subscribe. Hit the bell icon for more updates.